This question is the last question from the 2014 Technology-Free Mathematical Methods exam. So therefore, being the last question, it's going to be the hardest. So it's worthwhile breaking down what this question is all about. It says here, a line intersects the coordinate axes at the points U and V. So that's talking about this point up here and this point here, with the coordinates U and V. Now the first thing I should make mention here is we've got one too many letters. See, we've got a U and a V. That's too many letters. We can only solve one thing at a time. So what it would be ideal is that at some point one of these letters will be this but with something added to it, or will be in terms of the other letter. Remember, in terms of means it has that letter in the answer. So coordinates U, 0 and 0V respectively, where U and V are positive real numbers, and that 5/2 is less than or equal to U's and less than or equal to 6. So this is the domain of U. So the values of U, that being this friend here, must be somewhere between 5/2 and 6. This is a very important thing to make sure you do not forget, because a lot of students will gloss over the domain or the numbers that something can be in between, and they'll lose lots of marks. So, A, when U is equal to 6, the line is a tangent to the graph of y equals ax squared plus bx at the point Q with coordinates 2, 4 as shown. So if A and B are non-zero real numbers, find the values of A and B. So remind us, what was it that we were in fact looking for? Well, the A and B is from these friends up here. So we are trying to find the values of A and B in that quadratic. So probably what we'll do, we're trying to find values here. Why don't we go and substitute? So I'm going to substitute. We've got some coordinates here. X equals 2, y equals 4 into ax squared plus bx. So I get 4 is equal to ax, sorry, let's cross that out, a2 squared plus b2. So 4 is equal to 4a plus 2b. Label it as my equation 1. Alright, but I've run out of other points to substitute into that quadratic. How else could I do it? Well, we have been told in this particular example that U would be equal to 6. How could that be useful? Well, if I made U equals to 6 at this point, suddenly I've got two sets of coordinates here that I could find the gradient of the line. Well, why would that be useful? Well, hang on, didn't we just say this is a tangent? This is a tangent at this point. Therefore, the derivative will be equal to the gradient of the tangent. So, what we'll do is we'll find the gradient of the tangent. The gradient of the tangent is equal to y2 minus y1 over x2 minus x1. So this would be 4 take away 0 over 2 take away 6, 4 over negative 4, which is equal to negative 1. Oh, well, that's handy. So, negative 1 will be equal to the derivative of our top equation here. So, which will be 2ax plus b. But I've got an x in here. Oh, of course. This is the derivative at this point of x. So I can sub x equals 2. Get negative 1 is equal to 2a2 plus b. Negative 1 is equal to 4a plus b. There we go. Now I've got two simultaneous equations. So I can now solve simultaneously. So 4 is equal to 4a plus 2b. Negative 1 is equal to 4a plus b. May as well minus these. I get 5 is equal to 5 is equal to b. And so if I was to substitute 5 equals to b in this first one here, I think you'll find that negative 6 over 4 would be equal to a, which would be equal to negative 3 over 2 be equal to a. So what was the purpose of this question? The purpose of this question was to make sure that you could apply your knowledge of simultaneous equations, tangent lines, and gradients in order to solve a particular question. This required being able to use multiple skills in order to apply your knowledge. The rectangle OPQR has a vertex at Q on the line. The coordinates of Q are 2, 4 as shown. And we can see our very lovely triangle here. So, or what looks like a very lovely triangle. Find an expression for V in terms of U. Aha, told you there. So what we're now going to do, so we're no longer having U being replaced with 6. U is back to U. But we've got too many letters. So we need to turn this into something with U's in it. How on earth can we do that? Well, this particular question was very challenging for the state to do because people were asking that same question. What do you do? What can you do? So it's worthwhile comparing where this U and this V are. They're attached to the same line. So if they're attached, so U and V are part of the same line. So something about them must be the same. They're certainly not the same coordinates, but they would have the same gradient. So therefore, because they're part of the same line, they're certainly not going to have the same coordinates because they're completely different places. So would you agree, hopefully, that the gradient of that part must be equal to the gradient of this part? Well, they're the same slope, the same steepness, so they must be. So we're going to make those gradients equal. So I'm just going to do V minus 4 over 0 minus 2. It's equal to 4 minus 0, 2 minus U. And we're going to solve for V in terms of U. So we're going to get V minus 4 over negative 2 is equal to 4 over 2 minus U. And then what we'll do is we'll multiply both sides by negative 2, get V minus 4 is equal to negative 8, 2 minus U. And then we'll add 4 on both sides. And we can neaten this up by having one very splendid looking fraction. Which would be equal to or alternatively, it would be the same as either way. That is a perfectly fine way to have that answer. Find the minimum total shaded area and the value for of U for which the area is a minimum. So we need to find the area. Now the area of this triangle here, probably the easiest way to do this would be to say area shady bit is equal to the area of the full triangle minus area of that little rectangle there. This little rectangle here We'll have a width of 2, because that's what that coordinates say, and a height of 4, because that's what the y-ordinate says. So 2 times 4, this area is equal to 8 units squared, or squared units. And so we can go and do this triangle. So we've got a height here. What's the height of this triangle? Well, the height of the triangle is V. Now, since we don't want to deal with more than several letters, we can actually now replace V with this 4u over u minus 2. And a width here of u. So, my triangle is going to be half the base times height, minus 8. Half the base, which was half of u there, half times u times the height, which is 4u over u minus 2, minus 8, which is equal to 4u squared over 2u minus 2 minus 8, which is equal to 2u squared over u minus 2 minus 8. So I need to find a value for u that this would be the minimum. So to find the minimum, sub the domain extremes in would be one option, and 2, find the derivative and make it equal to 0. Remember, that was the idea of stationary points. The turning points, either the highest or lowest points, will be able to determine a minimum. So, in order to do this, we need to find the derivative. Now, at this, what we would need to do if we were to do this by hand, so we need to use the quotient rule, where v in this case would be equal to is u minus 2 negative 2, no, just be equal to 1, and u would be 2u squared, the derivative of that will be 4u, so this would be equal to u minus 2 4u minus 2u squared 1 over u minus 2 squared, which would get us a very complicated looking thing here. Make that equal to 0. So we should have 4u squared minus 8u minus 2u squared is equal to 0, because I just multiplied both sides there by the denominator, and 0 times u minus 2 squared is going to make that 0. So 4u squared take away 2u squared is going to be 2u squared minus 8u is equal to 0. And 2u over u minus 4 is equal to 0, u is equal to 4. So, what we'll do, I'll just put the little arrow here, we substitute u equals 4, u equals 5 over 2, and u equals 6. So, where did I get the 5 over 2 and the 6 from? Well, that came from our original part of this question here. That was the extremities of the domain. Now, don't be worried, you will not have seen this before, depending on which part of the course you're looking this from. If you're at the very beginning of Year 12, you will not have done quotient rule yet. You could just use your calculator for the meantime. So u equals 4, we'll sub into the area equation. So this equals to 2, 4 squared over 4 minus 2 minus 8. So this is 32 over 2 minus 8, which is equal to 10. And so with 6 squared over 6 minus 2 minus 8. So this is equal to, so 6 squared is equal to 36. 36 times 2 is equal to 72. 4 minus 8. 72 divided by 4 is going to be 1, and 18 minus 8, which is equal to, it's also equal to 10. What have I done here? 32 divided by 2. 16, what's it, 4 times 4 is 16, 16 times 2 is 32, 32 divided by 2 is going to be 16 minus 8, that should be 8 square units. Units. Now 5 over 2. Take away 8, which equals 17 square units. So, there we go. Lovely. So, we can see here when u is 4, we get 8 square units. When u is 6, we get 10 square units. When u is 5 over 2, we get 17 square units. So we can see that the minimum, the value for u, which would be a minimum, would be u equals to 8. U equals 4. The area will be 8 square units. A big box around it, so we know that that's our answer. And then for the maximum, we can say it's only worth 1 mark, so when u is equal to 5 over 2, area is equal to 17 square units. And there we go.